Welcome to General Psychology 201. My name is Eric Kim. This is a video lesson on scientific processes and hypotheses. To start off, when we use the word science, we could be using it in a lot of different ways, and there's some variations of it. So when we talk about science, we could be making reference to scientific knowledge, things that we know about physics, chemistry, medicine, astronomy. Those are things we can look up in a book, look up on the internet, but the knowledge generated from a scientist using the scientific process. We could be talking about science in terms of an occupation, someone who practices the scientific method. You find a lot of these at research institutes, universities, and how we're using language can be a little bit different than how we would be using it in everyday usage. So research would be one of those. It's more than just going to the library or looking stuff up on the internet. In the area of science, it would be conducting experiments to assess a claim as probably true or probably false. Now, the first chapter focuses on scientific processes. So we're using science in the context of a scientific process, a process or method for systematically investigating and testing claims about nature. And if you don't do it systematically, we run into a lot of problems which can lead us to false beliefs. So when scientists make a claim about the world around them, they conduct experiments where they test the claim, see what the world is like, and observe the world around them to collect empirical data to support or refute their claim. So the data will show that their claim is probably true or probably false. Or more often than not, we're not sure. So this chapter focuses on scientific processes. And some of the things that science teaches us, and this is why I think learning science is important, is that there are patterns in nature that we can figure out. Sometimes they're very obvious patterns, and sometimes these patterns are very subtle. The second thing, careful thinking is necessary. We need to be precise, and the world is nuanced. So we do have to be very precise about the language that we use and be very careful about how we're using it. And I'll show you a couple examples where we need to be precise in some of the language that we use and problems that can occur if we're not precise. And the other thing, last thing that science teaches us is that knowledge, scientific knowledge, is grounded in reality. It's grounded in the real world. So we're testing claims about nature to see how nature really does work. And it's complicated a lot of times, and there's multiple factors influencing the world around us, but we can know the world to some degree. So the next couple of images and pages that I have is that we need to be careful about the language that we're using and the questions that we're asking. Several questions may look alike, but they have different answers and are asking two different things. So I've got question 1 and question 2 here on this image, and if you hear them, it's a lot easier to confuse the two questions. If you have them written down, you're less likely to make that mistake. So the first question, you've flipped a fair coin, we'll assume it's a fair coin, and gotten 5 heads in a row. What are the odds that the 6th coin flip is going to be heads? So that's question number 1. Question number 2 is very similar, but it's asking a different question which has a different answer. What are the odds of flipping a coin and getting 6 heads in a row? These are two different questions with two different answers, and if you're not careful, you're thinking fast, you're multitasking, you're sleep deprived, it's very easy to confuse the two. So the answer to the first question is 50%. I'm just going to state that without proof. You can email me, talk about it, but the answer to the first question is 50%. What are the odds of flipping a coin and getting 6 heads in a row? It's 1 out of 64. Slightly different questions with different answers, but on the surface, they are very similar. Again, being precise is important, and looking at nuance is important. In this image, I don't think that this magazine really wanted to say what it actually did say. And in this case, grammar is important because if you don't have the commas in that phrase, you are going to say something you probably don't want to say. So, eat, Ray, love. Rachel Ray finds inspiration in cooking her family and her dog. I'm guessing that's not really what Rachel Ray kind of thinks. And in this, again, the point is that precision is important. Being able to make sure that the commas are there is important. These two signs, I'm pretty sure they don't really say what they mean what they say. So the top one, please don't touch bread with hands. Please use tongue. I'm going to assume that it's supposed to say please use tongs. The bottom picture, the wig and penis open for business. I'm pretty sure that's supposed to say the wig and pen is open for business. Again, paying attention to detail is important. And when you don't pay attention to detail, it can have different meanings. This sign, I'm going to assume that the sign really is supposed to say, did you know Kansas City welcomes 25 million visitors annually? Again, detail is important because if you're not paying attention to detail, you can make small mistakes which can have big consequences. Another one. Movie theater plays Wrong Guardian movie 3 times in a row. Not once, not twice, but 3 times in a row. Fans eager to see Guardians of the Galaxy 1, got a disappointing surprise at the Regal Cinemas this week. The debut seeking crowd watched in horror as the screen before them played the opening scene, not of the badass comic-based movie, but of 2012's DreamWorks kids flicks. Rise of the Guardians, not the same. So both have Guardians in the title, and if you're not paying attention, Rise of the Guardians, Guardians of the Galaxy, just looking for those key words, you can make some mistakes which can have major consequences. And if you don't understand why you're making the mistakes, you're going to repeat the mistakes and have difficulties making the change in your life that you want. And we'll come back to that in like 202. A hypothesis. So in your book, on page 15, a specific and tentative statement about a relationship between 2 or more variables. So scientists generate these predictions, these hypotheses. They can be between more than 2 variables, but for the sake of simplicity, we'll just say 2 variables. Generally, a hypothesis takes the form of an if-then statement. Sometimes that if-then statement is implied. So if you look at the examples down below, 3 and 4, the if-then statement is implied. One cautionary note is that when people use the word theory, they really mean hypothesis. So a theory is this tentative explanation that tries to integrate and account for the relationship of various findings. So theories we try to make sense of all of this information, all of this data into some sort of cohesive story, if you will, about how certain phenomena work. If we understand that story, that theory, then we can make a specific prediction from that theory. So the first hypothesis, if we make our cars more fuel efficient, then it will make them less safe. So we're predicting a relationship between fuel efficiency and safety once we understand this relationship between how cars work and engines work and how they're going to affect safety. I could have easily made the prediction, the hypothesis, if we make cars more fuel efficient, then it will make them more safe. Still a hypothesis, different prediction, but it still would be a legitimate hypothesis. Or I could say if we make our cars more fuel efficient, then it will have no effect on safety. The variables are fuel efficiency and safety. If the second one, if we have our employees wear back belts, then we can reduce the number of workplace injuries. So we're predicting a relationship between wearing back belts and the number of workplace injuries. 3 and 4 have the if-then statement implied. Driving while using hands-free cell phone increases the risk of accidents. So we're looking at a relationship between whether or not we use hands-free cell phones, and accidents. And the last one, drug testing reduces workplace accidents. Drug testing can vary, and workplace accidents can vary. So this ends the video lesson on scientific processes and hypotheses.